Hey guys, and welcome back. So let's discuss this workflow and the challenges that comes with it. Now we start off with a very simple geometry, and we try and aim to keep the geometry in Houdini as light as possible, and that's the workflow that we should be focusing on, that we should be adopting. And this way we have a light mesh that we can work with. It's easier for destruction. It's easier pretty much in anything to deal with it in stops and in Houdini. And that's how I was able to get all these fast sims, is because I'm using very light mesh. But the downside of this is that when you look at pretty much any fracture or any destruction in real life, there's so many details in the cracks and the interior faces. Well, we don't have that with the basic geometry. So what we need is we need to increase the amount of details. We can do two things. We can either use a higher resolution of the mesh and do two versions. We do one that we use for the sim, and we do another fracture that has more details. Okay, and I've been using these two different workflows based on the scenario. For example, in the destruction workshop, I used to up-res the mesh ahead and have it from the beginning have enough details. Now, the cool thing with that workflow is that you will have always the final resolution of the mesh. You will be able to work with it whenever you need. You will get accurate edge fracturing, and if you sim anything, everything is gonna look perfect, and it's gonna match. Now, with the destruction workflow, the geometry overall was lighter than this one. The entire building itself had less details than this one, so that's why I went with the up-res in scene. But in this example, doing the same thing was actually very expensive, and I wanted to keep the scene light so that everybody can work, even if you don't have access to something with high memory. So the second solution, is to do this process, the up-res process, at render time. Now, what does that mean? Well, we have, let's say this is a box. We fracture this box like this, and we have a couple of Voronoi pieces, and maybe another one like this, and another one like this. So the idea is we want to add details. So this is flat, it doesn't have any details. We're going to first need to subdivide the mesh, okay? And this is a normal subdivision process, but we're gonna do it at render time. It's similar to the remesh, where we triangulate the mesh multiple times. It's the same thing, or when you subdivide the mesh a few times. We're gonna do this process at render time. So if we have this flat geometry, when we subdivide it at render time, we're gonna get a lot more details. So this is one subdivision. We're gonna do two subdivisions. So this will become 16, and so on and so forth. So we have more details, okay? Which means that now if we have more points along this edge at render time. Now the idea is that we want to add noise to push these points in random direction. So this point will go up, this point will go down, this point will go like this, and this point will go like this. And that's gonna construct a new line that has more details, basically, something like this. So that's the idea. The problem is when we do this at render time, we never have access to the final geometry, okay? It's gonna happen at render time. We don't have a replication of that in the scene. And in our example, in my example, I have those cracks. I have that lightning effect that's gonna be propagating and following this geometry. Well, if we use the raw mesh in the scene, in the sim, and then render and displace everything, we're not gonna be able to displace the curves, because the sim is already done when we just have particles. So we need a way to recreate what we're going to do at render time in Arnold or any engine we're going to use back into Houdini. Well, the problem with that is that if we use Arnold, for example, and we create a noise pattern that uses Arnold noise, we don't have a way to replicate that back, because the Arnold nodes the Arnold procedurals or the Redshift procedural or even Mantra procedurals, noise procedurals, it's not guaranteed that we're going to have that same exact result in Houdini. Now with Mantra, we can make it work, but with Arnold and Redshift or any other engine, we're not going to be able to recreate that noise in SOPs. So we're never going to be able to recreate our mesh. And that means that these cracks will be done using the the lightning propagation is going to be offsetted compared to where the mesh is. And I didn't want that. I want it to be final. So we have to find a way to recreate the same thing no matter what the render engine is back into the scene. Okay, so the other main challenge for this is that in order for us to, let's go back, in order for us to do this process, let's say we take this geometry, we're happy with it, we're going to take this surface, the top one, and displace it along this vector and along this vector. So all the points here are going to be pushed along the, let's say, X and Z axis. Okay, and this is our Y axis. We're not going to push it along the Y because that will add details to, it's going to change the surface appearance of the mesh. So we don't want that. We only want to push it along the surface. We don't want to change the curvature. Okay, so if I have something like this, let's say something like this that has a curvature, and we want to displace it, we don't want to change how the curvature is. We want to slide the points along this surface. Okay, so in a flat, something flat like this, we can find a way. We can say, okay, I have this surface, it's pointing up, I'm not going to push it anything along the Y axis, I'm going to displace the point along the X and Y. And then we can create a mask that fades everything at the borders. Okay, so it only happens inside. Now that's great, but our geometry is changing every frame because of the transform. So if we manage to do this at one static position, what happens if we transform the mesh? This is never going to be correct, because that surface, for example this, after we transform it, it's going to be like this because of the transform pieces, and the box is going to be like this. So this vector is no longer applicable in this position. Okay, so let's say this is our new orientation, something like that, and this vector is no longer applicable because the mesh is now in a different position. So we need to make sure that whatever transformation is happening to the mesh, it's also happening to the to these vectors, to this custom vector that we're going to be creating. And because we have to do this at render time, the mesh has already transformed. So the displacement has to happen after the transformation, and we need to maintain proper orientation for everything. So that's something we have to solve. Then one of the other biggest issues is the UV texture. And this is why I try to avoid this technique, because solving this problem is very, very challenging because of all the complication that comes with it. Okay, so we have UV vector, we have a UV coordinate like this. Okay, so U and V, sorry, writing with the mouse. So this is our UV coordinate, it's 0, 0 here and 1, 1 here for this surface, let's say. When we displace these points, the UV coordinate is going to be transformed with it. Okay, so we're going to get distortion everywhere, and our geometry, our texture is going to look messed up. But if we look here, the texture is perfectly fine. There's no distortion. Okay, so we have to find a way to solve this problem, and each render has a different solution. I will show it with Arnold, and I'll potentially show it next week with Mantra. And this way we're going to be able to solve all the problems and have it a low res geometry, be able to displace it at render time, and still have a copy in Houdini SOPs, and then we're also going to solve the texture issue, that texture distortion issue. So we're going to be focusing on this entirely this week because I think it's very, very important, and it needs a lot of practice to get the workflow up and running. So we're going to focus entirely on this project this week, and hopefully you guys will be able to set it up from scratch and get everything working. Thank you for watching, and let's get started. Bye-bye.